So today we're going to continue talking about electromagnetic waves. Now remember, the waves as they travel, it's kind of like a slinky. So the waves are spread out and they're traveling either towards Earth. When we're looking at an object from space, we're looking at the light as it travels towards Earth. Now, we've said that an astronomer can look at the spectral pattern and they can decide, is that object moving towards Earth or is it moving away from Earth? The way they do that is by looking at the waves themselves. You see how the waves can change size. When the waves become more spread out, my wavelength is increasing. When the waves become closer together, my wavelength is decreasing. This change in wavelength indicates if an object is moving towards Earth or away from Earth. So in our first example, you see the light from the sun. We see a red wavelength, so it's a much longer wavelength. So what that indicates to us is this object is pulling away from Earth. The second example shows a blue wavelength. Now you notice the blue wavelength is much shorter. So in this case, my object is decreasing its wavelength, so it is getting closer to me on Earth. So what this is called is redshift, blue shift. When we look at the spectral pattern, and if the lines are shifted towards red, it indicates the object is moving away from Earth. So this would be called a red shift. Okay. Red means it's running away. Our second one is a smaller wavelength. So now the object is getting closer to Earth. So what we say, this is a blue shift. And the object is becoming closer. And what we're really looking at here is the wavelength. Because remember, we looked at our colors. Red has the longest wavelength, and blue and violet have the shortest wavelengths of the colors. Now, what does that mean to us when we look at a spectral pattern? So if we look, we have three spectral patterns here. So this is the one that we're going to compare to. So let's say this would be the standard. In the one above, you see we have these spectral lines, and they're all shifting more towards the blue end of the spectrum. So this is what we refer to as a blue shift. So we know if it shifts to the blue end, the lines are becoming compressed. So this is moving toward us. So it's coming closer. Now the next one, comparing to the same, this time our lines are all shifting towards the red. Now you notice it's not just one line, it's all the lines. When they shift towards the red, that means it's going to the longer wavelength, so it's pulling away from us. So it's moving away. Okay, so it's getting farther away. So that's the simple explanation of redshift, blue shift. Another way to look at that is with the Doppler effect. So the same thing is happening here. You notice when the ambulance approaches you, the lines become compressed. When it's pulling away from you, the lines get farther apart. So as the object, so if this is our ambulance, when these lines become compressed, it's a shorter wavelength. When the lines are farther apart, it's a longer wavelength. So again, if we just take a look, we have our wave, right? So the object is getting closer to us. We're compressing the wavelength. The object is moving away from us. We're stretching out that wavelength. So this again would be the Doppler effect, but it's directly related to redshift, blue shift. So astronomers are going to use this information to tell us if a star or galaxy is moving towards or away from Earth. So if we take a look at the one that is in our IMB, we have our standard that we're going to compare to, and then we're going to look at galaxy A and galaxy B. Look at the shift of the lines and decide, is the object moving away from Earth or is it getting closer to Earth? In this instance, both of these are actually moving away from Earth. They are both redshifted. Now you notice galaxy B is more redshifted, so that means galaxy B is actually farther away, because remember, farther away, they get away from us faster. So that is our redshift blue shift, and remember, redshift was one of the evidences of the Big Bang Theory, the idea that the galaxies are still pushing farther away.